Hello, my name is Cielo, and today we're going to be going over sensation and perception. This is an interdisciplinary science that explores the physiological aspects of sensory systems as well as psychological experience. It's about how sensory input comes in, we process that with our powerful minds, and we have some sort of experience resulting. And just a note on reference, all of this stuff is coming from our textbook, mostly from chapter 5, which is devoted to sensation and perception. So first off, just imagine you're on a busy city sidewalk. What things would you hear? What things would you feel? How do you stay focused when so much is going on? Like if you were to experience everything going on around you, it'd be overwhelming. How do you stay safe? How do you do anything of purpose? So this all relates to the sensory experience and how we filter that. Sensations are stimulus or stimuli. They come in, they hit a sensory receptor, and it results as a sensation. This process is known as transduction, which is the conversion from a sensory stimulus energy into action potential. When we think of senses, we normally think of the five senses. So there's vision and hearing, which both use various forms of waves, so like the electromagnetic spectrum or the waves traveling through a medium for hearing. This is also called audition. And then there's smell and taste. Smell is olfaction and taste is gustation. And these are known as chemical senses because they're actually interacting with various molecules and their properties. Touch is somatosensation, and this is the nervous system throughout our body. But wait, there's more. The book also talks about 4 other senses that have been kind of added to that lineup. There's balance, which is the vestibular system. Then there's proprioception and kinesthesia, which is body position and movement. There's pain, which is nociception, and temperature, which is thermoception. So all of these things add additional types of input for our bodies to understand. How do we sense these things? How do we talk about these as a science? How do we measure these? Well, you can measure the amount of stimulus energy, and you can see if it's noticed or not. So if it's detected at least 50% of the time, that's what they call the absolute threshold. Okay. And the difference threshold is similar, but it's like what is detectable. They also call it just noticeable difference. So can you tell the difference between this light and this light, or this sound and this sound? That's what they're talking about. And then if you can't quite notice it, maybe it's sensory input that you're taking in, but you just can't quite notice that it's there all the time. That's what they call subliminal. And so I kind of alluded to that on the bottom. If that caught your eye, it says subliminal using a slightly different color. So perception, the interpretation of sensory input and how it is experienced. So now we're talking about the brain is processing all this stuff. What does it do with that? Well, when we're first taking in a new input, it's using what they call top-down processing. Okay, so when we're first recognizing new stimuli. And then there's also bottom-up processing, which is when we are using that past knowledge, that past experience, to basically maybe look for something, or maybe we're fearing something based on a past experience. So we're using that past stimuli and integrating that into our knowledge. Sensory adaptation is the process that dulls perception of sensory input over prolonged periods of time. So if there's a ticking clock going, and at first it's annoying, but over time you just learn to ignore it, or traffic noise is similar. That's our brain basically adapting and phasing that stuff out. Like, let's not focus on that because it doesn't seem to be relevant. Let's focus on other things. Here on the right, I have a picture of a road because I drove across country one time, and tell you what, after driving hundreds of miles and on roads like this, your brain starts like phasing the stuff out. Even when you're trying to pay attention, it becomes very difficult. So I think this is another quality of sensory adaptation. Attention and inattentional blindness. There's a study at the top, Gorillas in Our Midst. And the study is about the people in the white shirts are passing this basketball. And observers were asked to count how many times they pass the basketball. But meanwhile, there's a man dressed in a gorilla suit walks by in the middle of the frame and then walks off. And it turns out only about 50% of the people were able to observe the gorilla because they were too busy focusing on the people passing the basketball. So this relates to signal detection theory, which is the ability to identify a stimulus when it is embedded in a distracting background. Basically, we can hone in and focus, but it's at the expense of seeing other things that are around us. Gestalt principles of perception. This is a way that we kind of recognize basic patterns of things, and it's easier, I think, for our minds to grapple with these bigger chunks rather than each individual thing. So proximity, similarity, continuation, and closure, they're all different aspects of this. And I think the complicated part is as this comes out, it might extend into other things like stereotyping and that kind of thing. So yeah, there's just interesting questions and more than I can get into here. In closing, there's the same stimulus. It's an outside force and it's measurable in some way. But from that, we have different sensations. We all have a range of different abilities too in sensing these things. And through that, we process that information and we have diverse perceptions.